at the back of our Shapes of Polynomials practice. All right, so very simply, we are asked just to sketch each polynomial. All right, so what do we have here? So in order to sketch a polynomial, we've got to ask a few questions here. We need to ask A, what are the roots? And we will sketch those once we get them. Okay, then the next question is we're going to ask is, okay, well, what is the degree of the polynomial? And lastly, we're going to ask, what is the leading coefficient? And these two together are going to tell us something about end behavior. In other words, does it trend to infinity in both directions, or does it trend to positive infinity in one direction, negative infinity in the other, or does it trend to negative infinity in both directions, or positive infinity in the left and negative infinity in the right? And those are our three different possibilities. And we get that information from our degree and our leading coefficient. Lastly, as a test, we can make sure that we've drawn the right graph by finding the y-intercept as well. Okay. So that can be our D. Okay, so for question 1, we're going to start with what are the roots. Okay, so to find roots, I put 0 in for y, and I solve for x. So this tells me that any of these three things multiplied together, any one of them could equal 0, and that would make this whole expression equal 0. So that means x minus 2 could equal 0 as a possibility, and that would mean if I add 2 to both sides that x could equal 2. That's one of my roots. I could also find that x minus 4 could equal 0, and therefore x could be 4. Or I could say that x minus 6 could equal 0, and therefore x is 6. All right, and then, like we say, we will just sketch that guy out. So the y-axis is not very important here, so I'm put my x. So I'll just draw a little y here. And I can see I have roots at 2, 4, and 6. I'll label those as 2, 0, 4, 0, and 6, 0. I wonder if I try to focus this, I can become even clearer. It's fine. All right, then next we want to know what's the degree of this polynomial. Well, I can see 1, 2, 3 factors containing x, so it's a third degree. If I picture a third degree polynomial, I picture something that looks like this, 2 humps in it, or something that looks like this. Okay, and then lastly, I need to ask, well, what's the leading coefficient? So leading coefficient is the, if I was to expand all this out, it would be the value of the number in front of the highest power of x, which in this case would be x cubed. Now, what do I focus on? I really focus on the number in front of each of these x's and the number in front here. In fact, they're all 1, and they'd all be multiplied together. The leading coefficient is 1, but actually I only care that it's positive. Okay. So if a leading coefficient is positive, that means at the end of the day, as we approach positive infinity, our graph is going to try to reach positive infinity as well. And I know that because this degree is odd, and I can think of other odd degree polynomials with a leading coefficient that's positive. For example, a straight line. This one has, looks like so. Steepness of 3, and it hits at 1. And you can see that the right hand trends toward positive infinity. Okay. So let's go back and let's take a look at these patterns here, and maybe we can give some properties to them. This means we have an odd degree, but it's a positive leading coefficient. And this is the opposite if that's a reflection. So this would be still an odd degree. Means they point in opposite directions because they're odd. However, we would have a negative leading coefficient. This means we have an even degree and a positive leading coefficient. And this is an even degree and a negative leading coefficient. Okay. So with this information, I know that my end behavior is going to be that I'm going to point toward positive infinity with the right and negative infinity to the left. And so then I can just connect the dots here. I can say, okay, well, it's going to go up, it's going to loop down, and it's going to pass through here. And that means my y-intercept is negative. So I'm just going to double check with my y-intercept to make it sure it's negative. So I'm going to say my y is equal to 0 minus 2 times 0 minus 4 times 0 minus 6, which is actually just a way of saying what's negative 2 times negative 4 times negative 6, which is 8 times negative 6. So y is negative 48. And it's negative, so that's okay. That actually works with our graph. We'd have a negative y-intercept. All right. Okay, so let's move on to the next question. So we're going to go through this one maybe a little bit more quickly. So we have the polynomial, question 2. Y is equal to negative x plus 1 times x plus 2 times x plus 3. Alright, so A. So first, we're going to start with our roots. We'll set this all equal to 0. And then we're going to look for our roots. Our roots are, we can see x is negative 1 here, negative 2, and negative 3. So I'm going to start by graphing this, and the y-axis there, and I'm going to make the negative x a little bit bigger, because these guys are all in the negatives, so it's going to be negative 1, negative 2, and negative 3. Alright. So next I need to worry about the degree. And I need to worry about the leading coefficient. What is the degree? The degree is again a third degree. So again, I should expect my ends pointing in opposite directions. The leading coefficient here is a negative. Coefficient. And so that means instead of pointing up like this, is going to be a reflection. It's negative in front. It kind of reflects the pattern over the x-axis. So instead of pointing up to the positive infinity, it'll be pointing downward. And it'll be pointing upward up here. And so it's just going to go through like this. Great. And again, we can see a negative y-intercept. So I might just check my y-intercept quickly. And so I'm actually going to just not even write the ones this time. Just going to say y is equal to negative, pardon me, not even write the zeros for x's. So I'm just going to write this is 1 times 2 times 3. This y is a negative 6. So that means this is the value negative 6 here on the y-axis. And that's okay. It's not positive, and so that's a way we can check to make sure we've drawn the right graph. All right. Let's move on to question 3. Okay, so for question 3, I'm going to find the roots. So it's going to be 0 is equal to x plus 3 times x plus 1 times x minus 1 times x minus 3, which gives me x values that are negative 3, negative 1, 1, and 3. So I'll draw a little sketch of what that could look like. And that means I have values at negative 1, 1, 3, negative 3. All right. So next I need to know my degree is 4. So that means I expect a graph that looks kind of like a W or an upside down W, depending on the leading coefficient. And the leading coefficient in this case is positive, so that means I'm going to be looking at this guy here. So there's a rule of thumb that says that if your leading coefficient is positive, it's always going to end going to positive infinity, no matter what else happens in your diagram. So we're going to try to draw this diagram without even remembering that a degree of 4 has both ends pointing in the same direction. But of course, all even degrees do. So I'm just going to try to connect the dots through here. And again, it ends up with positive infinity. I also have this positive y-intercept. So I'm just going to test my y-intercept. So it's going to say that y is going to be equal to 3 times 1 times negative 1 times negative 3. Negatives cancel, so it's really 3 times 3, or 9. So the y-intercept is at 0, 9, which is this point. 0, 9. And that works. It's not negative, it's positive. So that means we, chances are we at least did something right there. All right, let's move on to the next question. We're going to get a little more interesting now with question 4. This one says, okay, we'll start with our roots. And we have 0 is equal to negative x times x plus 1 times x minus 4 all squared, which tells me that I have roots of x is equal to, I have a 0 here, a negative 1, and 4. I should have 2 roots of 4 here, and they're equal roots. 2 equal roots of 4. And the 0, in case you're wondering, is because this is the same thing as saying x minus 0 times x plus 1 times x minus 4 times x minus 4. All right. So, when we plot this thing, I have a negative, wait, no, positive 4, right, so it's going to be out here. Negative 1, and a point at 0. Okay, so I have then I ask what is the leading coefficient. I look in front of the x's and multiply all the numbers in front of the x's together, and I get negative 1 times 1 times 1, or negative 1. So I have a, oh, I'm getting ahead of myself. It's 1, 2, 3, 4th degree. 4 factors. And we have a leading coefficient that is negative. Alright, so that tells me we're going to be pointing downward like this. at the end when we go to positive infinity. We're going to end up at a negative value. And also we see we have the same root twice being squared. Same factor twice. That means we're going to have a kiss. This means a kiss. We're going to kiss off the x-axis and bounce back. So it's going to look something like this. And I guess it has to bounce back up to get back up here. And dip back down. And there we go. We have a fourth degree, meaning it's even. They're pointing in the same direction. And then the leading coefficient was negative, so it's pointing downward when it goes to positive infinity. Okay, we can't really use the y-intercept as a test in this question because the y-intercept actually is 0, 0. All right. So let's do another color here, lavender. Let's move on to question 5. So this tells us that we have, so we're going to start with our roots. And that will be saying 0 is equal to 3x minus 1 cubed, which is the same thing as saying 3x minus 1 times 3x minus 1. So x is a value of positive a third, positive a third, positive a third. Don't really need to list it twice, but we do have 3 equal roots. And this means we're going to get an inflection point. Okay, so that means at this point, 1/3, we're going to get a saddle point. So it's either going to look something like that, or maybe something like that. Okay. So to answer which one, we're going to need to know about the degree. This is a third degree, 3 factors. And the leading coefficient is, I look at all the numbers multiplying in front, so it's a 1 times a 3 times a 3, only looking at the axis, times a 3, so it's 27. So the leading coefficient is positive. Alright, so that means we're going to end in positive infinity like this. So we're going to end up here, we're going to come down, and we're going to make an inflection point, and then bend down again. So we're going to have some negative y-intercept. That is an inflection point. And let's just test the y-intercept. Make sure we were on the right track here. So very simply, I'm going to put in 0 for x, which means the 3x's all disappear, and I end up with negative 1 times negative 1 times negative 1, which is negative 1. It means I have a negative y-intercept, so that's the value negative 1 here. Okay. Moving on to question 6. Okay, so we're going to start with our roots. Alright, and so we're going to 0 is equal to 2x minus 5 times x minus 1 times 3x plus 4. Alright. And so what are our x values here? X values are 5/2, 1, and negative 4/3. Okay, so I'll sketch that. And we get a value negative 4/3 out here. That's a little bit more than 1, so that means this one's a little bit closer. 0, oh no, 1, obviously not 0. And 5/2 is like 2.5. So it's like 5/2 out here. Roughly to scale, and that's all that's really important. Okay. So, moving on. We have, we need to find the degree. This is a third degree polynomial. And our leading coefficient, again, is this invisible 1 times a 2 times the invisible 1 times a 3, or 6. So we have a positive leading coefficient. Oops. Alright. And so that means we're going to end going to positive infinity. So I'm going to come down like this, bounce back up like so, and scroll back down. There we go. So if we're right, then we should have a y-intercept that's positive. So let's just test. So that's going to be y is equal to -5 times -1 times 4. I'm just not even writing the terms with x's, because when x becomes 0, they all just disappear. And I end up with -5 times -1, which is 5, so y is 20. So we end up with a point at 20 there. And it's positive, so that can work. Okay, good stuff. Moving on to question 7. All right, so question 7 says, here we go, y is equal to negative x minus 3, all raised to exponent 4. Okay? And that's to say that y is equal to negative x minus 3 times x minus 3 times x minus 3 times x minus 3. Okay. So what are our roots? Well, that means we're looking at when 0 is equal to negative x minus 3 times x minus 3 times x minus 3 times x minus 3, which is to say that we get x values that are equal to 3, 3, 3, and 3. So that is going to, we talked only really briefly about this. It's a pretty rare case where you have 4 roots at the same place. So let's hit 3 here. And, oh right, we should probably think about the degree. This is a even degree, so 4th degree. And we have a positive leading coefficient. So when you have 4 roots at the same place, you end up with just a slightly wider kiss. In this way or in this way. Alright, and so this is an even positive leading coefficient. Oh, no, sorry, it is a negative leading coefficient. And that means it's actually going to face downward when we go to negative infinity. And it's going to rise up and form this really fat, weird kiss. And come back down. So it's going to have some negative y-intercept. I'm just going to double check that that's true. It's y is equal to negative version of -3 times -3 times -3 times -3. That becomes 9 times 9, negative 9 times 9, which is -81. So it's going to hit down here somewhere at -81. All right, our last question, which maybe I'll just write right on here, is this one. So we're going to start by finding the roots. So the roots are, we're going to set 0 equal to x, and that's x minus 0, right? That's what that looks like. And x plus 2, x plus 2, x take away 2, x take away 2. So that means to make all this whole thing equal to 0, x could have a value of 0, could have a value of -2, -2, 2, or 2. All right, so these guys mean we're going to have a kiss at -2 and a kiss at 2. So that means we have some root at -2, 0, and 2. We have a degree of 5. So that means we should be expecting something like that, or something like this. And lastly, we know that the leading coefficient is positive. So that means it's going to end pointing upward to positive infinity. So let's see if we can connect these dots here. So it's going to come down and kiss back up, but then it has to bounce back down to go through 0, and it's got to do the same, bounce back up to come to -2. Then it's got to do another kiss, so it's going to bounce back down, like so. All right. And those are how we sketch these polynomials. So let me know if you have any questions about any of this.